Today we're continuing where we started yesterday with slopes and equations of lines. Today we're going to talk about writing linear equations in slope-intercept form, which we express as y equals mx plus b. So we know that y and x, these are our y values, and these are our x values. M is our slope, we talked about that yesterday. And b is what we call a y-intercept or a y-offset, which is where our graph runs into the y-axis. So I think these are all things you've heard of before, and we're going to make sure that we understand how they translate from telling us about points on a line into making a graph. So we have a story here. Andrew wants to buy a smartphone that costs $500. His parents will pay for the phone, and Andrew will pay them $50 a month until the amount is repaid. The loan repayment is a linear situation in which the amount y that he owes is dependent on the number of payments x. So x is our independent variable, and y is dependent on x. So this is our x and y values. Our process of looking at this is going to be that he owes $500 at first. Right, so he owes 500 and he's paid off this much times 50. He pays off 50 a month, so minus 50 times 0. So at time 0, his parents have just paid for the phone. He hasn't paid back anything yet, so he still owes the full $500. But we go 1 month into the future. Now he did owe $500, but he now has paid $50 one time. So 500 minus 50, he still owes $450. So he paid off 50, there's $450 left. We kind of continue that trend where he pays another $50, so now he's paid 50 two times, once in the first month, once in the second, and he owes $400. And you can see that we're subtracting 50 each month because he's paying off another 50 each month. So if we continue that process, we're going to do 50 times 3. He'll still owe $350. And then when we subtract 500 minus 50 times 4, he'll still owe $300. So our f of x is 500 minus 50 times whatever our x value is. Notice here we're just plugging in our x value for the number of times he's paid. So the f of x just decreases 50 a month. As an equation, we would say that y, the amount he still owes, or f of x, they put f of x here, but y in the problem, so I'm going to put y, equals 500, and then each month we're taking away 50 times the number of months that have passed. So just what we saw here as this pattern. The slope is the number in front of the x. So our standard form of writing slope-intercept is y equals mx plus b. The way I've written it here, we actually wrote b minus mx. So it's slightly different, or b plus mx. I just reversed these two terms. To be clear about how adding and subtracting works, we could do y equals 500 minus 50x, or y equals negative 50x plus 500. So these two terms, the positive 500 and the negative 50x, we can write those in either order. It doesn't change anything. So this would be standard slope-intercept form where we have mx plus b. But this way kind of made sense for the story as far as he owed 500 and we're taking away 50 per month. But either way, our slope is the thing in front of the x. That's our coefficient of x, so it's negative 50. And our y-intercept is the constant, the one not with the x's. That would be 500. It wants us to name two solutions. We came up with 5 already, so we have a solution. Let's take x equals 1. So that means there's a point at 1, comma, our y value there was 450. Let's go down to 3. At x equals 3, we saw that y would equal 350. So all of these combinations of x and y values are points on this line. If we were to draw these on the graph, the first one we had was at remember x is our horizontal axis, y is vertical. X comes first, and our horizontal number line was the first way we ordered numbers. So x is horizontal, like our number line, and then our newly added direction y goes up and down. So our x value of 0 right here, if we go up to the corresponding y value of 500, that would be our first point. Let me erase this circle here. So our first point on this graph would be at 0, 500. Our next point, if we went to where we were at 1, would be 1, 450. Our next point would be 2, 400, then 3, 350, then 4, 300, and so on. You see that we're following the same pattern each time. Our change in y is 50, our change in x is 1, or actually, sorry, our change in y is negative 50 because we're dropping. So that was our slope, negative 50, for every time we go one step forward on x. And if we looked at that as a fraction, our slope, negative 50 over 1, so our rise, or in this case our fall, because it's negative, is 50, and our run is 1. So we go down 50 over 1 for every step that we take. And then if we wanted to, we could connect all of these points into a line. If you do that, it would be very good to have a straight edge when you do it so that you're able to draw a straight line. I don't have a straight edge on this little tablet, so I'm going to draw a terrible line. I'm not even going to try, sorry. We're going to not. So when you draw your lines on a graph, make sure you're using something as a straight edge, either a ruler or an ID card or something that will let you draw a nice straight line, unlike I am not able to do here. Okay, so moving on, slope-intercept form. If a line has a slope m and a y-intercept at 0, b, then the line is described by the equation y equals mx plus b. We saw that in the last one where our 0, b, our y-intercept, the 0, 500, lands on the y-axis. That's why we call it the y-intercept because, all right, I'm going to try to draw the line. If we draw this line right here, then where it runs into the y-axis, that is that b value, or the y-intercept. All right, so we're going to write an equation of a line in slope-intercept form. We have a slope of 3, and we have a point at 2, 5. We want to find the y-intercept. To do that, we know several things. We know the slope, and we know an x and y value that lie on that line. Whatever the equation of the line is, it has to be true for every x and y value that lie on it. So we could take our standard form y equals mx plus b. We don't know what b is, so this is what we want to solve for. But we do know a y value on the line that corresponds with an x, so these go in as a pair, and we have a point that gives us an x and y value that go together. So we'll plug in our y value of 5 where y is, and we'll plug in our slope value of 3 times x. Our x value at this point is 2, plus our unknown, which is b. And now this equation must be true because this point is on the line. For any point on this line, this equation will always be true when we plug in a matching x and y value. Simplifying this would say 5 equals 6 plus b, and then we'll do our algebra step of taking away 6 from both sides, and then rewrite as -1 equals b, or b equals -1. So that would be our y-intercept. Our full equation then, in the generic form, we don't put in a y and an x because it's true for all y's and all x's on the line. So our standard form would be y equals -1 times x. Oh, sorry, that was wrong. That's our intercept. Our slope was 3. Sorry, 3 times x, and then our y-intercept is -1. So plus -1 is the same as saying -1. So our equation is y equals 3x minus 1. It looks like they want us to draw a graph of it here. So we know that our y-intercept is -1. So we have a point on our y-axis right here at -1. Our slope is 3. So if we have a slope of 3, that's the same as 3 over 1. So we have a rise of 3 and a run of 1. So I'm going to count up 1, 2, 3, and then over 1. So that's a rise of 1, 2, 3 units and a run of 1 to the right. So then if I wanted to find another point, I could do the same thing, go 1, 2, 3, and 1. We also know that 2, 5 was on this line, so we could have just gone over to 2 and then up to 5, and we would have found this same point. So we have a lot of information here that would help us graph this line. Going on to example B, we have a line that passes through 2 points, 0, 5, and 2, 13. We learned yesterday that we can calculate the slope if we know 2 points on a line. We do that by finding our change in y over our change in x, which is y2 minus y1 over x2 minus x1. We're going to label those things here so we can keep them straight. Our first point, we label the x-coordinate x1 and the y-coordinate y1. Second point, we label x2 and y2. Now let's calculate the slope of this line. We have m equals y2 is 13 minus y1 was 5, and x2 is 2 minus x1 is 0. If we simplify that, we get 13 minus 5 is 8 over 2, which is simply a slope of 4. Now we can do what we did in the first problem and plug in one of our x and y values. That would allow us to calculate our y-intercept. But if we are a little careful and look at this, we can see that we don't need to do that step because we've been given the point 0, 5. So when x is 0, y is 5, and that is the definition of our y-intercept, is whenever x is 0, whatever value y is, that's our y-intercept. So we know that we have a point right here at 0, 5, so that this 5, this y1, was also our b value. That's our y-intercept. So our equation of this line will be y equals our slope of 4 times x, and then we do plus b. B is a positive 5, so plus 5. And to draw our line, we can plot these 2 points. We had 0, 5. The second point is at 2, 13, which is like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, somewhere like up here. And then we could connect those two with a line, but yeah, it's way off of our graph. So that's how we would find that one. If we're given 2 points, we first need to calculate the slope before we can write the equation of the line. This one gives us a slope and a point. This one gives us 2 points. Those are very similar to A and B, so I'll leave these two as practice. So you can pause the video, try those two just like we did on A and B, and then we'll continue down here. On example 3, we're looking at graphing. Basically, the way I showed it on the first graph is what we're going to be looking at here. So we get our equation in slope-intercept form. It has to be in this form in order for us to be able to graph it, because we have to be able to clearly see the slope and the y-intercept in order to make the graph. So in this case, we already have y equals 5x minus 4. It's already in slope-intercept form. Our slope is 5, and our y-intercept is negative 4. Remember that we need the sign in front of the number as well. We're going to plot the y-intercept first because that's an easy point. It's always on the y-axis at x equals 0, and we just go up or down a certain number. So in this case, we've gone down to negative 4. That's this point right here. And then we're going to use our slope, so this 5 over 1. Once again, we call this our rise over our run. We're going to go 5 up because it's positive 5. 1, 2, 3, 4, 5. So they drew this arrow here up to here. And then we're going to go over 1 to the right. And even if we had negative 5 over 1, our run is always positive because we never write negative numbers on the bottom of a fraction or a ratio. So our run will always go to the right. We may go down instead of up if there's a minus sign, but we're always going to the right. Let me put that 5 back. Okay, So we found our next point at 1, 1 right here. And once we have 2 points, we can line up a straight edge, like a ruler, and between them, and draw a line. If you have any 2 points in space, there's only ever one line that can connect them. So there's only one way to draw a line that connects, a straight line that connects any 2 points. All right, so go to B. We're going to do this as an example together where it's not already worked out. We've got 2x plus 6y equals 6. This is not in slope-intercept form. It does not look like y equals mx plus b. So first, we have to do some algebra to rearrange it, just like we did with literal equations, so that y is all by itself on one side. We're going to deal with our adding and subtracting operations first. We have 6y, and we've added 2x to that. So let's do minus 2x to move the x's to the other side. And we'll have 6y, and then on this side we have 6 minus 2x, but I'm going to write it as negative 2x plus 6 so that I can clearly see the mx and the b in their normal positions. We have a coefficient in front of y, so we've practiced some of these as well. We need to divide that away, and we have to be careful to divide every single term by that 6. So anytime there's a plus minus, we need to divide each term. So we divide our y term, our x term, and our constant term all by 6. And then we're going to simplify. 6y over 6 is just 1y. Negative 2 over 6 simplifies to negative 1 over 3. That's our slope. And then 6 over 6 simplifies to 1. So on our graph, we're going to start by using our b value. That's our y-intercept of positive 1. So on our y-axis, we have a point at 0, positive 1. Then we use our slope, so negative 1 over 3, that's our rise over our run. And since this is negative, you could think of this rise as actually being a fall. We go down 1 space, and we go 3 to the right. So I go down 1 and to the right 3, and I land right here as my next point. If I wanted to get more points, I could keep doing that, because I could find another point by going down 1 and right 3 again. And I can even find a point by reversing both directions. So instead of down and right, I could find a previous point by going up and left instead. So I could go up 1 and left 3, and that would have been the point from which I go down 1 and right 3 to get to this one. So I can go up 1 and left 3 again in the reverse direction, and all of these are points along that line. Then we'll use our ruler and we'll connect all of those, which again, I don't have a ruler I can use here, so it's going to look terrible. We don't want your line to look like that. All right, you're going to do some practice on these. There's 2 more to try, very similar to the example we just did. So pause the video, try those 2 on your own, make sure that you're able to make the graphs of those. But first, rewrite these in slope-intercept form. It has to be in that form for us to know what the slope and the y-intercept are. Okay, so determining solutions of equations in 2 variables. So these are our linear equations, 2 variables, x and y. We're going to identify the slope and y-intercept of the graph that represents each linear situation and interpret what they mean. Then we're going to write an equation in slope-intercept form and use it to solve the problem. Let's see how we do that. For this problem we have, for one taxi company, the cost y in dollars for a taxi ride is a linear function of the distance x traveled in miles. The initial charge is $2.50. So this initial means beginning, and that is a key word that tells us that this 2.50, $2.50, is our y-intercept value. So that's our charge before any miles have taken place. So this is our b value. And the charge per mile, so we don't know how many miles we've gone, so the number of miles is going to be our variable. The charge per mile, how much we're doing each time we have x, will be our slope. So we have 35 cents per mile. We want to find the cost of riding a distance of 10 miles. And you can probably really easily see that if we do 10 times 0.35 and add that to 2.5, we would get our answer. So this is something you can probably do as mental math really easily, but we want to see how to formally do that by following all of these steps. That way we can handle more complex problems as well. So the rate of change is 35 cents per mile. So $0.35. So the slope is 0.35. When we're talking about slope, we're not going to use units. We're just going to talk about a number or a ratio. So this is not that helpful as a slope. Remember earlier we talked about not leaving decimals for our slope. We want fractions. So if we wanted to express a number of cents as a fraction, that would just be like saying 35 cents out of every 100, 35 out of $1. So that's the same thing as moving the decimal over twice would be like multiplying by 100. We could simplify this fraction because both of these are divisible by 5, and we could simplify this to say that the slope is 7/20. So 0.35 would be the decimal version of the slope, but in order to get a rise over run, we would want to see that as a fraction. The initial cost to travel 0 miles is $2.50, which doesn't actually make a lot of sense at 0 miles, because if you don't go anywhere, you're not going to pay $2.50, right? But this is just how we think of it, as whatever our fee per mile is, we're adding $2.50 to that. So the y-intercept b is going to be 2.50, 2.5. Then our equation will be y equals our slope, 7/20 times x, that's our mx, plus our y-intercept is positive 2.5. So that is what we would look at. Now it says find the cost of riding 10 miles. Miles is our x, that's our variable. So we'll just do y equals 7/20 times 10 miles plus 2.5. If we simplify, this is 7 times 10 is 70/20. That's 7/2, which if we want to combine it with this and make it a decimal again, that would be 3.5. So 3.5 plus 2.5 would be a total of $7 for that ride. Looking at our next example, a chairlift descends a mountain to pick up skiers. I'll go through this one as well. If you want to pause the video and try this one yourself and then check with what I did, feel free to get the practice, but I do want to see how we go through this again just so we have more examples. So the height in feet of the chairlift is a linear function of the time in minutes since it begins descending as shown in the graph. We want to find the height of the chairlift 2 minutes after it starts descending. So we can just look at the graph and see at 2 minutes, we're looking for this point right here. It looks like it's halfway between 4,200 and 3,600, but since it doesn't fall right on an intersection like these points, it's a little tough to say if it's exactly halfway. So what we're going to do is figure out our slope, our y-intercept, and then write our equation to figure this out. Our y-intercept is the easy one. That's on our y-axis, and it happens at y equals 5,400. So that is our y offset there. And then our slope, we are looking at basically our rise over our run. So rise over run. If we go from this point to this one, the two that are marked, our rise is 5 steps down, which is 3,000 feet. And since we're going down, this is going to be negative 3,000. And the time that we went over was 4 minutes. So our slope, without simplifying, is negative 3,000 over 4. Notice that that's the same checking from the graph as it would have been from the equation if we did y2 minus y1 over x2 minus x1, labeling this x1, y1, x2, y2. we would have had 2400 minus 5400 over 4 minus 0. So that gives us the exact same answer, negative 3000 over 4. Simplifying negative 3000 over 4, we would do 4 times 25 would be 100, times 30 would be 3000. So we need to multiply by 25 and 30, which would be 750. So this is the same as negative 750, and I'll put negative 750 over 1 so that we can see our rise and run there. So our equation will be y equals negative 750x, so that's our slope times x, plus our y-intercept of 5400. To find out where the chairlift is after 2 minutes, we can plug in 2 for x. So I'll go down to the bottom right here, and we'll write our equation. Y, where whatever our height is negative 750 times 2 minutes plus 5400. That 750 times 2 is 1500, so y equals negative 1500 plus 5400, which comes out to be 3900 feet. So that is actually exactly halfway between 4200 and 3600, would be this point here at 2, 3900 is where the chair is after 2 minutes. Okay, so they have some practice for you to do here. Similar things to what we've been doing. You have a story with a table, and you have some graphs to do examples for, and then some equation examples where you're given a function with f of 0. So on this one, just remember that f of 0 means the y value when x is 0. So our input x is 0, our output y is negative 7. So this is just saying an ordered pair of 0, negative 7. So here you have two ordered pairs, and here essentially again you have two ordered pairs in order to write the equation. So that'll be your extra practice for today, and then that's it.